All right, so last time we finished building our map here. And we had our player inside there rolling around and things like that. And I mentioned that, and we also, I just at the end of class last time, brought in some normal classes like the player class, which is not a mono behavior. So we're going to be using this to kind of represent what's going on in our world programmatically, so we can make decisions, keep track of like how many hit points and things like that a player might have. But in order to do some of this, we need to learn a couple of other skills. So what I've done currently is I reactivated, well, first of all, just from a little organizational perspective, you see my scene over here is a lot less cluttered. What I did is I created this empty game object called map, and I just drug all the rooms into it. Can I click? Let me just relaunch Unity. Yeah, so I just added an empty game object. You just right click, you say create empty, and I just named it map, and then I just drug all the rooms in there. So now I can just hide all those pieces of the map. Makes our thing over here look a little bit less crazy. Okay, so then what I did is I went ahead and for our player, which we remember I created a little package deal between our player and the camera last time. So the camera kind of drags that guy around. Was there a question online? No, nothing? Okay. But what I went ahead and did is I just drug our player out from our map over here because I want to mess with some collision stuff over here. Just learning a couple of skills. We can always drag them back in when we're ready. And then I went ahead and reactivated the cube that I had. And if right now he's got very little on him. So if you had deleted that cube, just create another cube and put it out there in front of him. So right now, if I hit play, I should just be sitting in front of the cube, but I see my whole world over there. All right, but we're going to be looking at some interactions between the cube and the player here. Okay, so going into our project, we have our box script. Let me just open that up. So I've cleared out most of the box script right now, because remember that box script used to have the thing that let us drive the box around, but now we've turned that into our sphere. That's our player. So this is effectively a brand new script. I just put a pre-populated it with a couple of things that we're going to talk about today, just to keep us moving through this stuff reasonably fast. So this is just a plain Jane mono behavior with a couple of things we're going to talk about in there. So I added to that cube that box script. Okay. Now that cube is also a rigid body. I have him using using gravity, so he'll drop down to the ground. He has a box collider, and so that will allow him to collide with have the physics allow it to collide with the ground. So I probably have it pretty close to the ground right now, but it's possible that he's hovering a little bit. Yeah, he's hovering just a little bit. So he didn't fall tons. All right, but in any case, that's our current state of things. Now, our cube also has this box collider, like I mentioned. Now, the box collider, I just left it as the default for right now. I think I've at least discussed this thing called isTrigger, and I'll talk about that a little bit more today. Let's see kind of what this does initially. So that's all this cube is. He's a rigid body with gravity who has a plain Jane box collider on him, and he has this box script that doesn't do anything when it starts. It doesn't do anything on a per frame basis, but I do have this function that I put in here. All mono behaviors have the ability. This is almost like in Java when we had the two-string method, that all objects come with a two-string method. All mono behaviors come with several methods that don't do anything by default. And one of these methods is called onCollisionEnter. And if you just start typing it in here, as long as you have your Visual Studio kind of set up reasonably well, it'll give you like the starting point for these different things. So there's another one called onCollisionExit. You just press enter on that and it'll put that function in there for you with the parameters it's supposed to have and that kind of stuff. Okay, so I can actually talk about collisions from different perspectives. So in this case, I can do one thing. This gives me the opportunity to do something programmatically when a physics collision occurs. All right, now my physics collision right now, let me just go back in here. When I run this, even if I didn't have that code in there right now, when I hit this thing, you know, I can slam that, man, I hit that thing hard. Where'd it go? We'll be a little gentler this time. There we go. Well, I was slightly more gentle, but in any case, the physics engine is doing the magic when I hit that guy, right? He's bouncing all over the place and stuff like that. That's nothing that we had to program. So by default, when we have a collision, we might be interested in just letting the physics do it because it's completely a visual event. But we might also want to do something programmatically behind the scenes when a collision happens. So imagine like maybe we're sword fighting or something like that, and the guy swings and the sword collides with the guy's armor or something like that. So fine, there might be this physics thing where the guy kind of bumps back or something, and that's what we want this game engine to do for us. But under the hood, we might have this object that is, you know, governing our enemy, and maybe we want to behind the scenes roll the dice to see how much damage just got done to him. So we decrement his hit points, that kind of stuff. So there might be some logic that's living behind the scenes that has something to do with things other than physics. Okay, so in my code right now, I have in here, I'm just going to get rid of this for a second so I don't have to talk about tags. We're just going to say collision enter. And then I'll go ahead and do collision exit too. So we'll get to see when these guys get called. So now I'm able to programmatically take part in two different events associated with a single collision. No, I guess I think that's reasonably accurate. So when I first enter that collision, onCollisionEnter will get called, and whatever I do in here will happen programmatically. When that collision, when they break apart and the colliders are no longer interacting with each other, this guy happens. Now this is on my box script. So I can say box collision exit, box collision enter. I'll go ahead and run this. Notice that my player script, which is on that, he does not have those functions written in there. So we are not programmatically doing anything with the player right now, but the box is printing some stuff out when he gets collided with. Okay, go ahead. Correct. yeah, I think this stuff down here, the update with all the left down stuff that used to be in our box script, I put it in our player script and attached our player script to our sphere for driving that guy around. But I didn't change the code. All right, so now when I run this, I'll go ahead and click on console here. You see that it says box collision exit. Just said it again. So as it's kind of being knocked around, oh, this is moving too fast for me. I'm not good enough at this game to. Did I make it public? There we go. That's more my speed. All right. So we can see that we are, collision enter, backup, collision exit. So we're able, and it's active as we keep colliding, uncolliding, whatever. Uncolliding, it's a thing probably. We're able to programmatically deal with that. But we notice this is all coming from the box collision enter. Now, that's because maybe I want to programmatically handle something happening between the box and any other object. And I want the box to be able to programmatically do something. So maybe, well, here, we'll put some logic in here in a few minutes. But I can also go into my player script. Now, make sure you're in your couple of questions that I had on Slack. Our player script is the mono behavior that's going to govern that object that's moving around on the screen. Whereas our player object here, this guy, this is our mimic of what we were doing in Java. This is going to be a data structure. It's going to sit behind. I think I already am creating an instance of this dude inside of my player script. But I'm going to be managing information about my player inside of that object. That guy has nothing to do with Unity. He's a plain Jane player object, just like we were dealing with in Java. And I can write methods in there and call methods and all that stuff. Okay, so what I'll do is now from the player scripts perspective, I'll go ahead and I'll, let's see, what is it on? It's not going to show up in there. Oh, it's capital O. Still not showing up in there. Let's assume that you have a situation like we have here. Now, I happen to already have the methods written over here, so I can just go and copy them. But what I can do is, let's say that I know I want to get the on collision thingy. I can just go to Google here and say Unity, and I can kind of remember like it's on collision, enter, or something like that. And so here's our scripting API. And you could just kind of grab the code from somewhere on there in case your Visual Studio is, I don't know, not behaving or something. All right, so there's my on collision enter. So I'll go ahead, and this is from the player perspective. This is from that game object, the player's rigid body perspective. I'll go ahead and say player collision enter. And I won't put the collision exit. I wonder though if since I did that now, yeah, very interesting. Wonder why it came up for the other one and not this one. Go ahead.
Is there some sort of way to like the settings turn on to where the
there probably is, yeah, but I haven't messed with it enough to know. And then on top of that, I'm also using the Mac version of Visual Studio, which is probably getting a little bit less updates than the PC version of Visual Studio. So maybe that's a good thing or a bad thing. They're probably a different development team working on it too. But there probably is. In fact, you see I have this thing called attached to Unity for debugging. So maybe something with that would make it be more predictable for that kind of stuff. But in any case, you know, you could always just go and Google it and grab, you know, a piece of code real quick and be able to go through life. All right, so now my player should announce when he's involved in a collision. The box should announce when he's involved in a collision. The box paying attention to both entering and exiting the collision. So I go and run this. I'm gonna clear this down here just so we have a. All right, so we have box collision enter, box collision enter. So I must have bumped it twice maybe. And then player collision enter. So the player is also aware. Now I left it. I have a box collision exit. I have two box collision exits. Why is the box being collided with twice? Say this again. They're running different scripts. Yeah, those the player is running the, oh, he is. See, I'm always testing you. So there's your answer. Why is it writing it twice? Well, because the player's running the box script as well as the player script. So here we'll remove that. There we go. Now the player is running the player script. The box should just be running the box script. So now these guys should. Yeah, we just got a single one this time. Okay. So now what kinds of things might we want to do programmatically? Printing stuff out, that might be handy for us to do debugging or something like that. But when you really think about a video game, maybe we want to have it where after we hit the you know, once the cube is hit 3 times, maybe that enemy dies, something like that. Okay, so we want to kind of have some logic, some counter we're going to keep track of behind the scenes. So let's just go and add some logic for that. We'll start off just in the box script. We're going to say, hey, I want to keep track of a counter. So we're going to say private int count. And when this guy first comes into existence, we can set count equal to 0. Or you could have just initialized it to 0 up here. It didn't matter. Okay. So we have a count of 0. And then let's just do, I'm going to take the collision exit out of here. We'll just keep it simple. So every single time that we enter a collision, we're going to go ahead and just do a count plus plus. And then we'll concatenate on the value of count to this guy. All right, so this is going to show that behind the scenes, we're doing some logic with this, where every single time a collision happens, count is going to go up. All right, so there's my enter 1, there's my enter 2, there's my enter 3, 4. One thing you may have noticed, colliding with the floor the very first time. Actually, I wasn't doing that on purpose, but it is the next thing I was going to cover, so we're going to say I did it on purpose. So without me doing anything, notice that the box has already been involved in a collision. It just hasn't been involved in a collision we care about, right? It's fallen and it's hit the floor, and we don't care about that. We actually only care if it has a collision with the player. So we have to have some way of talking about who did we collide with. So inside of Unity, we have something called tags. So what I'm going to do is for the player object, and I actually already have it turned on for the player, but your default for this would have said untagged. So for your player, when you click on that, you see the inspector up top. There's a thing called tag, and there's a drop down, and there's a whole bunch of default tags. All right. So one of them happens to be player because most video games have a player. So it decided that might be a tag you're interested in, but you can invent your own tags. Tags are just strings, names you're going to associate with stuff. All right. But I'm going to go ahead and I'll use the player tag that's here. And similarly, let me just go over to my cube and let me rename this guy. I'm going to name him enemy. All right, so my cube's going to be the enemy. And for the cube, I'm going to go to the tag and I'm going to say add tag. And I'm going to hit the plus sign on this. And I'm going to create a tag called enemy. Go back to my enemy. So now I have an enemy tag in that dropdown. Okay. I don't know if I'm going to use the enemy tag yet, but I've labeled programmatically both of my combatants here. Now, from an enemy's perspective, he only wants to increase his count when he bumps into something that is the player. So that first collision that we're having right now, that just, hey, I collided with something, count plus plus. We only want that count plus plus to happen if we're dealing with the player. We can come back into our code here, and inside box script, inside of on collision enter, we want to ask a question before we do this. We're going to say, if collision is the object, the collision object that was created, and that guy has a game object associated with it, and that game object has a tag, and that tag is of type string. And I'm going to check to see if that string is equal to player. Technically, in this case, the double equal sign would work since we're using string literals, but because in Java, I really emphasize that thing that the double equal sign is unsafe to use for comparing strings unless you know why it will work. I'm using the dot equals method for strings in C#. Okay. So now we're only going to increase our count and print something out when we collide with a player. Make sure I save that. So right off the bat, notice we don't have, nothing new has shown up here. This was the stuff that was already there. I'll go ahead and clear that and I'll start it again, just so you see. Oh, the player still has his collision written that he will collide with anything. All right. I really want to just go into the player script here, and I'll wrap this in if collision dot game object something weird with that script, I'm guessing. So the player is only going to spit something out if he collided with the enemy, not with the floor, or not with anything else. This function will get called whenever anything any collision occurs. Okay. Back in here, I'll clear this. We'll run it again, and we'll see nothing shows up. All right. Both of those things have been involved with a collision with the floor, but because they weren't enemy or player, nothing happened. Now I'll go forward. We notice that the box collision has occurred. So we have a count of 1. Another one has occurred. We have a count of 2. Another one has occurred. We have a count of 3. So we're seeing that internal logic happen where every single time a collision, I just added something. So now what we want to do is maybe have after 3 collisions, our game object gets destroyed. And you can have like, you know, animations and things like that. You think back to like the Mario game when Mario dies, he kind of pops up on the screen. You know, it's like whatever it is. It's something. Like there's some music that plays, but that's actually called a ragdoll animation. That way it's in 2D. You imagine back in old Nintendo days, they didn't have a lot of memory and processing power, so they had to figure out ways of having things happen using very little system resources. But for us, we just want to make it just die, just disappear, go away. So we're going to go into Google here. We'll just do Unity game object destroy. All right, so here's our scripting API. So there is an overall function that's part of the Unity engine called destroy, and I can pass it a game object and he'll destroy it. Great. So now back here in my code, from the box scripts perspective, we can just go ahead and ask another question in here. If count is now equal to 3, then I'm going to destroy the game object that this script is associated with, which will stop this script from running because this guy's no longer a thing. All right, so after 3 bumps, the war has ended. There's 1, there's 2, there's 3. All right. I turned off all the blood and gore I had programmed in there, you know, because we want to keep this family friendly in the classroom. So it's all right. So any questions about that? Hopefully what I wanted you to see from this little example is maybe a reason why you might want to have the physics collisions that automatically happen on the screen occur, but also be aware of the collisions programmatically, because you might want to keep track of some extra stuff, because maybe that becomes meaningful in terms of the logic of your game. Make some sense? And that's leading us down the path of why we might want to keep track about our players. So for instance, when a player dies, or rather when a enemy dies, maybe the player wants to keep track of a kill count or something like that. We'll just do a simple version of this. There is a way for objects to send messages. So actually this game cube can send a message to, and we'll look at how to do that. We'll talk about something called a singleton probably next class. But as our enemy is dying, they can send a message to the player game object and say, you know, you've killed me. So the game object can then, you know, keep track of its death count based on being notified that something's occurred. We'll just keep it simple and bring our player into this a little bit. So I'll go into my player CS. So this is just my my game object here. And I'm going to create a private int kill count. And when a player is first created, he has 0 kills to his name. And we'll go ahead and give him a function. It's called add kill. That sets this kill count to 1 more than it used to be. And if we want, we can do a public int get kill count. And we'll return this dot kill count. So we have a way of getting at that private member. I'm not sure why I didn't make name private. Okay, so we'll still build a player, giving him just his name, but he internally keeps track of his kill count, and at this point he has 0 kills. So inside of our player script, every time we bump into an enemy, we want to keep track of how many bumps we've had with enemies. This is only going to be good for this current example where we only have 1 enemy in play. Otherwise, we'd be keeping a count of multiple enemies, but just to keep this simple for, let's say private int count. So our player script will also keep a count, and I'll start that off at 0. So we'll say count plus plus. We'll say if count is equal to 3, which means assuming we only had 1 enemy, the enemy just died, because I've been keeping count too. So if the enemy just died, then I want to go ahead. Let's see. Then I want to go ahead and let the player that's associated with this particular script know, well, increase his kill count. So I already have a player object here that I instantiated in start. So I can say this dot the player dot add kill. That's what I called it, right? Add kill. And then I can print out kill count is this dot the player dot get kill count. All right, so the player is only going to announce something when he's successfully had a kill. And the way he's managing that is using our player object. He's keeping track of a bunch of stats, let's say, about you know, the game currently inside of that player object. That's the rationale on why we might want to have that. I'll go ahead and clear this. We'll run 2, 3. The enemy died, and then the player prints out his current kill count, which is 1. All right. Now, what do we ultimately want to accomplish here? So we just learned about collisions. We can use collisions for all sorts of different things. Maybe eventually, once we go to start killing our enemies inside of our game, we might come back to something like this. But in the larger scene, dealing with our map here, if you remember back to our MUD that we were writing in Java, a player always knew what room he was currently in. That makes sense? A player always knew what room he was currently in. How do we let a player know what room he's sitting in? We're going to have to, well, there might be some other ways of doing it, but maybe we do this with collisions. All right. So maybe as the player is going through the door, he collides with something that lets him know that, oh, you just ran into a collision. You are now in another room. here is the room associated with that guy. That makes some sense? All right, so let me go here to Unity send message. Okay. So let me show you an example of this. So we're going to go back into our player script. Actually, we're going to go into our enemy script. All right. So right before this guy gets destroyed, he's going to go ahead and say, send message. And the message he's going to say, let's just do something. And he's not going to pass any parameters here. And then what we're going to put inside of our player script sure it doesn't have to be public. It does have to be public. So inside of our player script, we have a function called do something that all he does is print something out to the screen. And we'll say player do something. Then inside of our box script, right before he dies, he's going to send a message to anyone who's listening to do something. Okay. Oh, I have to register him as a receiver. You see, we got an error message here. Everything we expected to happen happened, but it said do something has no receiver, no game object was willing to listen to that. So I need to set him up as a receiver. Damage. It should have all right, so this had to be something that he instantiated. All right, I'll give you a good example for that rather than spending more time on it right now. But we have a couple of different ways that we can send messages. We're ultimately going to do this through a singleton, but effectively we can yell about messages that occur. We can send tags, whatever we want to do, and then have something occur as a result of that. So once this is working, we wouldn't have to have the player keeping track of the number of collisions it's been involved in. Instead, the guy on his deathbed will just scream that, okay, I've been killed. The player will then increase its kill count. Something like that would be what we'd want it to do. So now, if we think about how are we going to handle what room we're currently in, I have to put him back in the building, I think. Well, we don't actually have to put him in there. I'll just talk about it at the high level here. So if the player starts off in this room, and this room has a room object associated with it. So if we think about from when we did our MUD in class, each one of these was an instance of a room. So that means each one of these game objects should create an instance of the room class. Just like right now, our player is creating our player script is creating an instance of the player. So we have one instance of the player that belongs to the game object that is our sphere, the player. And then for every single room, we ultimately want the script for that room to generate a instance of room. So when this guy comes into existence, instantiate room associated with him. Instantiate room associated with him, so on and so forth. All right, so that when this player rolls from this room into this room, maybe passing through some sort of gateway, and we have perhaps a collision on that, and that collision becomes, we maybe want to have physics turned off for that guy, so we don't just slam into the wall. But as he passes through that collision, he becomes aware of, oh, I just transitioned out of the old room into the new room, and now the player needs to know about the room he just entered. That makes sense? So what we're going to be looking at next time is the mechanism by which we're going to do that. And I'll go ahead and at the high level introduce what a singleton is, because that's what we're going to be looking at next time and how we can accomplish using it. And then I'll get us a working example of send message. All right, we already talked about design patterns. We talked about one of the design patterns being singleton. I'm sorry, being MVC, model view controller. So we have a singleton design pattern. And this guy says it is a good idea to have data that multiple instances, I'm just going to say of an object. It's a good idea to have data that multiple instances of an object need access to. Stored in a single place, rather than pass that data to each individual object. All right. Now, if you want to come up with a real life example of what this looks like, let's say you're in an apartment and you have 3 roommates and all of you share a car. All right. Well, you can each get a copy of the key made. No problem. Costs a little money, whatever. But at any point in time, only one key is, you're only going to be able to put one key in that car at once. So maybe it makes sense to have a single drawer at the apartment that the car keys are in. And if the keys are there, car is available. Keys are not there, car is not available. Something like that. There is a world where that might make sense for us to have a single place that holds the information, the card keys in this case, that all the individual roommates have access to. So in this case, maybe there's going to be a global collection of all of our rooms. Each room knows about their particular instance, but maybe they register themselves with the, I don't know, the gamekeeper. Okay, they're going to have an empty game object that's going to have a script on him, and he's going to advertise himself to the other folks, and you'll see how that's going to work next time. But having that overseer that everybody can talk to might allow us to have some communication between our various instances in our game. All right, questions, comments, concerns, bribes? you wanted to start updating your game, you could go ahead. I won't give this as an assignment yet, but you could go ahead and start putting colliders on your entrances so that the ball has to kind of maybe roll over it, something like that. Put a little like speed bump if you wanted to do something like that. Make it pretty flat. All right, I'll see everybody on Friday.